This is Luis Ribeiro from PDMFC, and I'm going to bring you today the privacy tool. The main objectives of the privacy tool is to prevent unauthorized access to sensitive data and to help organizations ensure that their data is protected and compliant with regulations. So we're going to provide a tool that does anonymization of data and the conversion between multiple formats. Okay, the global architecture for the tool, it supports a set of inputs. It has an engine that can parse that inputs and then allows the administrator to define the rules of the anonymization and the structure. And this can be done through configuration, and you don't need to code anything else. It goes into an engine and then generates the output file, either into a log or into a database. It can also be integrated with the Homomorphic encryption already presented by my colleague Bakar and with the other tools from Sphinx. The current status, we support SQL integration, so we can read and write into databases. We also support XML and JSON and plain text files, and receiving data through HTTP integration and doing parsing on that type of data, irrelevant of its format, as long as it's text or if it's something that can be text-wise. On the data encryption front, we support all the algorithms that currently OpenSSL provides, adding also AES-FFX, which is a format-preserving encryption standard ratified by NIST. And because we can transform the data, we can also do only attribute-based encryption and select only the few attributes that we want to do. On the anonymization front, we also support the algorithms provided by OpenSSL, and we can do tokenization data masking. We also provide a web GUI where you can import and export the data flows and define them and inspect the data that goes into all of them. It has a debug mode where you can go into very verbose mode where to detail the inputs and outputs of each of the components. So it's easy to identify mistakes when you are defining data flows, and allows the user to define the data flows dynamically. So this is the general look and feel for the GUI. We can drop in whatever inputs we want. We define the rules to parse that inputs, then the processor rules to transform it, and then where we want to write it. Okay, so this is just a simple workflow to demonstrate either the GUI and what type of operations we can get. Okay, what we have planned for future work here, we want to do referential integrity on data masking, which means that we take an input database, we write it into the output database, apply the anonymization rules, but the referential integrity between the identifiers and the keys are maintained. This it's a bit tricky in terms of algebraic complexion, but that's the work that we plan to do on the next few months. We also plan to do a schedule refresh where we can do, let's say we have a production environment, we want to ship the data into the test or quality environment, and we want to do data refreshes regularly. We want to automate the process so that it's not only done manually, but can also be done daily or whatever. This implies developing a scheduling agent and also do the work to do the distributed workflow. For the next few months, it's also planned the integration with the other components and with third parties and the agent-based data acquisition. On the use case front, we'll support the use case defined on Work Package 2 and also provide tools to automatically anonymize incident report data and support STICs out of the box. For the pilots, we aim to deploy it with the end users to perform the testing and validation, fill in the gaps that we identify from this validation, and then define what next for the tool. This is it.